In this video, we're going to look at over-the-air updating. That is, sending the firmware and the file systems to the controller without using cables. So this project supports a number of different options available. We're going to cover those and cover things like user credentials, which are necessary, how this all fits in with remote observatories, and we'll also do a little demonstration. OTA uses a network connection to upload a new firmware file and a new file system file to the controller, and they have to be in binary format, hence the extension .bin. After uploading those to the controller, you then have to do a post configuration to actually set the focuser back to what your particular settings are. This is what we have at present. In a future release, I intend to overhaul the update side, so you won't have to do any post configuration at all. In this project, OTA is not included by default. It's an option in the config.h file. And there are two different options available to do OTA, and in order to use the OTA you have to know what the user credentials are, otherwise you will not be able to sign in. So looking at user credentials, they're specified in a file called OTA defines.h, which is in the firmware subfolder defines, and currently they're set to this. You can easily change this. And those credentials are used when you actually sign in. So here we're trying to access the OTA server, and we require a username and password. And in this particular case, it's a dedicated OTA system or server running on port 9999. And again, you have to be able to use those credentials to sign in. One thing I should point out though is that you can actually change these in the management server to something that probably has more meaning for you. Alright, so in config.h, when we look at that, there are two different choices. We've got a dedicated server, OTA server, or we can have OTA under the control of the management server. So you've got a choice. In terms of option 1, which is using the OTA server, this is what the memory arrangement looks like when they're both completely independent of each other. But under option 2, where you use OTA management server, you can see that it's embedded within the management server. So if you don't have the management server running, then there's no way you can access that particular OTA function there. To generate the firmware.bin file, we click the verify button. So within the Arduino IDE, we use the little FS plugin to generate the Filesystem.bin file. And so those two files are what the OTA software will use to, it'll upload these two into the appropriate folders. After the firmware.bin file has been uploaded into the correct app partition by the OTA server that we're running, it then flags the bootloader and says, instead of booting off app 0, please boot off app 1. And so that's why when you reboot, the bootloader will load the new firmware off app 1, and it will flag the previous app 0 position as not in use. The OTA server, of course, is also responsible for uploading the file system. And the Filesystem.bin file, when you go out and you select it, it will upload into the existing little FS data partition that the controller is using, and that will overwrite what's actually there. As I've just said on the previous slide, you generate the firmware.bin file by using the Arduino IDE, and then click verify, and that generates the firmware bin file. And to generate the Filesystem.bin file, you use the little FS plugin, but instead of uploading to the ESP32s3, what you do is you choose the option called Build Little FS Image and Sketch Directory. And I'll actually go through all of this and show you. Alright, so before we even start of thinking about uploading a new firmware, the first thing we have to do is we have to make sure that whatever you've got there now is actually running OTA. And you must do that with the controller connected to the actual computer itself. So you connect the controller to your local PC using a USB cable. And so you have to upload this over that USB cable first, and then we'll get into actually doing the OTA itself. So we have to prepare it all ready for a handover to OTA. And so we do that, and we run the Arduino IDE. We'll do all the changes in the firmware and the defined files, and make sure that the desired OTA option is enabled. We then turn around, just click the upload button to upload the firmware, and then we use the little FS plugin to upload the file system to the controller, and then we go through all the post configuration settings to configure the controller to be what we want. So that process must be done first. And I would point out this is a one-time only. Once you've got firmware which supports OTA, in other words, OTA is enabled in that firmware, you only have to do this step once. Next, when you get a new version of the firmware arrives, you don't have to repeat this step, because the current firmware you've got running in the controller already supports OTA. Alright, so what happens when new firmware is released? Well, we prepare the new update. We basically create a folder. Let's make an upload folder, and we download the new firmware into that update folder and extract the files. We then save the current configuration files to the upload folder, and we move the focuser to a specific position. I always like to send it to home. So to download the configuration files, here they are here. The only ones you need are controller board.json and controller focuser.json. So we've got our controller running away happily. We've just downloaded the two configuration files by right mouse clicking the link and go File Save As, and we've put them in our upload directory. So now it's time to get ready to create the actual bin files we're going to use via OTA. So the process will be that we load the new firmware into the Arduino IDE, and we set our target board to whatever that is for the board that we're using, and we go through like it's a normal install that you did for your particular system. So we set the focuser and fixed step guide and the steps per revolution and the controller mode, access point station, read Wi-Fi config, all those types of things. We also do the OTA type, and if there were other things such as MSDN name, duck DNS, whatever, we would enable all those settings that we wanted our controller to have and what it should currently be configured as. Instead of pressing the upload button, because at this stage we don't even have the controller connected, we've just got the Arduino IDE running by itself. So we click verify to generate the firmware bin file, and we're going to, once you've done that, we'll copy it to the upload folder and we'll leave the Arduino IDE running because we want to come back to that and upload to generate the Filesystem files. So when you compile, it tells you in fact where it stores the bin file, and this long path here just before sketch users, etc., that's the path. So you go to that path, and there it is. We're going all down the tree, and we end up with this one called ino.bin, and we copy that to our upload folder. So it's only that file which we need. To generate the Filesystem bin file, we've already got the Arduino IDE running. So we click the Alt+P option to bring up our list of options, but instead of selecting the upload to ESP32, we select build little fs image and sketch directory, and what that does is it generates a file called mklittlefs.bin in the actual firmware folder itself, and then we copy that and upload it to the upload folder, as it were, copy it there. So this is the option, build little fs image and sketch directory. Well, it comes up when the press Alt plus the P, and we select that, and then when we go out after that's finished, you can see here that in the same folder as the firmware, it's generated the mklittlefs.bin file, and that file we then copy into our upload directory. So we've got everything we want now in an upload directory to be able to update the controller with a new firmware release. So moving along to step 5, what we're going to do is we're going to log into the controller, and we're going to access the OTA server, whether it's in the management server or standalone, and we're going to then set the OTA mode to firmware. We'll click select file and navigate to where the bin files are stored. That's the upload folder, and the moment we click on it, the upload will start. There will be a progress bar, and when it's finished, there will be an update successful page. So what does that look like? Well, here we are. I'm using OTA server, and in this instance it's enabled and it's running on port 999, and first thing I do is I go to that, and it asks for a username and password, which is Otago and the default, and then click sign in. So after we've signed in, the first thing we do is make sure we're uploading firmware first. So we'll make sure that the OTA mode is set to firmware, and you just click it and it will toggle between firmware and little fs. So we'll choose firmware, and then we click the button called select file, and then we go out and we browse for it, and this should be in your uploads folder. I'm just too lazy, I'm using the same slide. So we get the firmware bin file, and then it will come back and it will say it's uploading that bin file, and it'll go away and it'll gradually wind up, and eventually you'll get to this stage of update successful. And so what we've done is we've uploaded the firmware into the unused app partition, and now we've got to upload the file system. So we click get back, and we're now in the stage of uploading the actual file system itself. So we're still in the OTA server, and this time we're going to select little fs from the OTA mode. We'll browse to select the mklittlefs.bin file, and then the upload will start just as before, progress bar, and when it's update successful, we'll click go back. So here we are. I've toggled this button by clicking on it, and we're now ready to upload the file system. I then click select file button, and I do a browse and I select the mk_fs.bin file, I get the same progress bar, and this will load a lot quicker because the size is significantly less. And once it's finished, I should get an update successful and go back. I would stress, if you get an update fail, you go back and just repeat the process. Okay? I've had it update fail once, but I wasn't sure whether that was me or something else. But all I did was click go back and then repeat it, and it worked. Right, so what's next? After uploading the firmware, what do? Well, we go to the management server. I've got the OTA server running here in this window, you see. And this one, I've clicked reboot on the nav bar, and it's brought me to this page. So we want to reboot the controller. So we click the reboot button, and it will come up with a slide saying, are you really sure? And the answer is, we have to reboot in order to switch to the new app partition which contains the new firmware. And so that change is done right now when you click OK. And so here we have a sign message that says, hang on, wait a minute, the controller's rebooting. And so this page is on a timeout of 15 seconds, for which stage the controller should be up and running.